68 kilometers per second. That's not a typo. Nordic telescopes just captured something impossible, a perfect ghost shell expanding around an object that shouldn't exist. Within hours, an antitail formed, pointing toward the sun, breaking every rule we thought we knew. And here's what's terrifying scientists. The ring is getting sharper, not fading. Stop. Think about that for a second. When dust expands in space, it disperses. Always. It's one of those laws so fundamental that questioning it feels like questioning gravity itself. But 3I Atlas, this visitor from beyond our solar system, is doing exactly what physics says it can't. The shell is organizing itself, the antitail is growing stronger, and the brightness patterns make zero mathematical sense. Scientists are concerned because our models aren't just slightly off, they're completely broken. The Atlas Telescope network in Chile first flagged this object 3 months ago as a routine interstellar visitor. Routine, that word seems almost laughable now, because what they found next has forced emergency meetings at NASA, triggered new observation campaigns at the European Southern Observatory, and has astronomers worldwide asking a question they never expected to ask. What if everything we know about how matter behaves in space needs to be rewritten? The implications stretch far beyond one strange comet. If 3I Atlas can create structured shells that defy dispersion, if it can generate antitails that ignore radiation pressure, if it can maintain brightness patterns that violate thermodynamic predictions, then we're not looking at an anomaly. We're looking at evidence that the cosmos operates by rules we haven't discovered yet. And that's not even the strangest part. 3 days ago, spectroscopic analysis from the James Clerk Maxwell telescope detected something that shouldn't be there. Organized carbon chains arranging themselves in the expanding shell, not random molecular scatter, not chaotic dust distribution. Organized structures forming in real time, as if the material ejected from Atlas follows instructions we can't read. Dr. Sarah Chen at the Minor Planet Center was the first to notice the pattern. She'd been tracking Atlas for weeks, expecting it to follow the path of previous interstellar visitors. Borisov had been predictable, a classic comet following classic rules. Oumuamua had been weird but manageable, tumbling, accelerating slightly, but still within the boundaries of what non-gravitational forces could explain. Atlas shattered those boundaries in its first week of detailed observation. The data didn't make sense. Chen ran the calculations 3 times before alerting her colleagues. The brightness drop was too sharp, too precise. Objects don't dim like that unless material is being ejected in a controlled burst. But controlled by what? Cometary outgassing is chaotic, violent, unpredictable. This was none of those things. That's when the Nordic team made their discovery. Using a new imaging technique that combines multiple exposures to detect faint structures, they captured what everyone said was impossible. A perfect ring, geometrically precise, expanding outward from Atlas like a shockwave frozen in time. The ghost shell was real, measurable, and growing. Nobody expected what happened next. The antitail appeared 12 hours later, captured by the Lowell Discovery Telescope during a routine tracking session. Antitails aren't unprecedented. We've seen them before when Earth crosses the orbital plane of a comet, creating an optical effect where we see the dust trail edge on. But Atlas's antitail was different. It pointed directly sunward regardless of viewing angle, defying the geometry that creates normal antitails. Dr. Marcus Webb at JPL pulled up the trajectory data. The viewing geometry was wrong for a standard antitail. Earth's position relative to Atlas couldn't produce this effect, which meant they were looking at something else entirely. Material actively streaming toward the sun, fighting against radiation pressure that should push it away. The math broke completely. Solar radiation pressure is non-negotiable. It's why comet tails always point away from the sun, why dust gets blown outward, why small particles can't fall inward past a certain point. The pressure of photons streaming from our star creates an invisible wall that lightweight material can't cross. Atlas's antitail was crossing it anyway. Emergency observations were scheduled. Every available telescope that could track Atlas was pointed at the mysterious visitor. The Hubble Space Telescope cancelled other observations to capture high-resolution images. Ground-based observatories from Chile to Hawaii coordinated their efforts. The James Webb Space Telescope, still in its early science phase, was tasked with infrared analysis. What they found made the mystery deeper. The ghost shell wasn't just maintaining its shape, it was becoming more defined. Sequential images taken over 72 hours showed the ring sharpening, its edges becoming clearer rather than more diffuse. Dust clouds don't do that. They can't do that. Particles in space follow predictable patterns of dispersion based on their size, velocity, and the forces acting on them. Those patterns are so reliable we use them to study everything from stellar winds to galaxy formation. But Atlas wasn't following the patterns. Dr. Jennifer Park at the European Southern Observatory was monitoring the spectroscopic data when she noticed the first hints of structure within the shell. The carbon chains weren't randomly distributed. They showed signs of alignment, as if responding to an organizing principle nobody could identify. It wasn't magnetic. The field strengths were too weak. It wasn't gravitational. The mass was too small. It wasn't thermal. The temperature gradients were wrong. So what was it? The question echoed through observatories, universities, and research centres worldwide. Every explanation failed under scrutiny. Every model broke when applied to the data. And as more observations poured in, the situation became more impossible, not less. We need to understand something crucial here. When scientists say something is impossible, they're usually being dramatic. What they mean is highly unlikely, or challenges our current understanding. But with Atlas, impossible means impossible. The physics doesn't just bend, it breaks. The math doesn't just struggle, it fails completely. Take the brightness variations. Comets brighten and dim as they approach and recede from the sun, following predictable curves based on how much ice sublimates and how much dust gets released. Atlas's brightness curve looked like someone was playing with a dimmer switch. Sudden drops, plateau periods, sharp increases that had no correlation with its distance from the sun. The velocity measurements were equally baffling. That 68 kilometers per second figure? It's not just fast. It's impossibly fast for where Atlas is in its trajectory. Objects gain speed as they fall toward the sun, following precise mathematical relationships discovered by Kepler centuries ago. Atlas was travelling at inner solar system speeds while still in the outer regions, as if it had been accelerated by something we couldn't see. Dr. Alan Morrison at the SETI Institute raised the question everyone was thinking, but nobody wanted to say out loud, could this be artificial? The scientific community recoiled. After Oumuamua, any suggestion of artificial origin was met with extreme skepticism. Too many papers had speculated wildly. Too many headlines had sensationalized mundane observations. But Morrison wasn't a sensationalist. His analysis was careful, methodical, and focused on one simple point. Natural phenomena follow natural laws. When those laws are consistently violated, we have to at least consider other possibilities. Not alien spacecraft, not ancient probes, just artificial, meaning the product of processes we don't understand yet. The debate raged in journal preprints and conference calls. Most scientists rejected any artificial hypothesis, arguing that we simply didn't understand natural processes well enough. But they couldn't explain the observations either. Every natural mechanism proposed fell apart under examination. Sublimation jets couldn't create perfect rings. Fragmentation couldn't produce organized structures. Electromagnetic effects couldn't generate sunward pointing tails. Gravitational interactions couldn't explain the velocity anomalies. One by one, every tool in the astronomical toolkit failed to explain Atlas, and then it got stranger. The second Nordic observation run, conducted a week after the initial discovery, revealed something that shouldn't have been possible to miss. The ghost shell was rotating. Not tumbling chaotically like debris would, but rotating smoothly, maintaining its structure as it turned. The rotation period was exactly 11.3 hours, precise to within seconds. That kind of precision doesn't happen naturally. Dr. Lisa Chang at MIT ran the stability analysis. For a dust shell to maintain coherent rotation without dispersing, the particles would need to be held together by forces we couldn't identify. It was like watching individual grains of sand organize themselves into a spinning ring without any visible connection between them. The antitail, meanwhile, had developed structure of its own. High-resolution images showed it wasn't a smooth stream but consisted of discrete filaments, braided together like cosmic rope. The filaments maintained consistent spacing, consistent width, consistent brightness. Everything about them screamed order in a universe that tends toward chaos. We were witnessing something that challenged our fundamental understanding of how matter behaves in space. And the challenge wasn't subtle, it was absolute. Consider what we know about dust dynamics. Every particle in space is subject to forces: gravity from nearby objects, radiation pressure from stars, electromagnetic forces from charged particles, collisions with other particles. These forces create predictable behaviors. Dust disperses in predictable patterns. It forms tails in predictable directions. It brightens and dims in predictable ways. Atlas violated every prediction. The European Space Agency scrambled to redirect Mars Express for observations as Atlas passed through its field of view. The images captured were low resolution but confirmed what ground-based telescopes were seeing. The shell was real, the anti-tail was real, and both were behaving in ways that shouldn't be possible. Dr. Robert Hayes at Oxford proposed a radical solution. What if Atlas wasn't a single object? What if it was a swarm of smaller objects maintaining formation? This could potentially explain the shell and the organized structures, but it couldn't explain the anti-tail, the brightness variations, or the velocity anomalies, and it raised its own impossible questions. How could a swarm maintain such perfect formation across interstellar distances? Every answer led to more questions. The carbon chain discovery changed everything. Spectroscopic analysis doesn't lie. Those molecules were there, organized in ways that suggested complexity beyond random chemistry. The chains showed signatures of aromatic compounds, cyclic structures that usually require specific conditions to form. But the conditions around Atlas were the opposite of what these molecules needed. Space is cold, irradiated, and diffuse. Complex molecules break down under ultraviolet radiation. They can't form in the vacuum. They certainly can't organize themselves into patterns, yet that's exactly what was happening in Atlas's ghost shell. Dr. Amanda Foster at Caltech led the chemical analysis team. Her findings were unequivocal. The molecular structures were not only present but actively forming. New compounds appeared in successive spectroscopic observations. The shell wasn't just maintaining organized chemistry, it was building it. That's not a typo. The shell was creating complex molecules in open space. Foster's team checked and rechecked their instruments. They compared observations from multiple telescopes. They ran every possible calibration and error analysis. The results held. Atlas was a chemistry lab operating in the vacuum of space, creating compounds that shouldn't exist under those conditions. The implications rippled through multiple fields of science. Astrochemists scrambled to understand how complex molecules could form without pressure or temperature. Astrobiologists wondered if they were seeing a new mechanism for organic chemistry in space. Physicists struggled to explain what energy source could drive these reactions. And through it all, Atlas continued its approach, silent and mysterious. The trajectory calculations added another layer to the puzzle. Based on its velocity and path, Atlas originated from the direction of Vega, passing through our solar system on a hyperbolic orbit that would take it toward the constellation Aquarius. But the non-gravitational accelerations made precise predictions impossible. Atlas wasn't just following an orbit, it was actively changing course in small but measurable ways. These weren't the tiny accelerations seen with Oumuamua, explainable by outgassing or light pressure. These were discrete, directed changes, as if Atlas was making corrections to its path. The changes were small, fractions of a meter per second, but consistent and purposeful. Dr. William Turner at the Harvard-Smithsonian Center for Astrophysics led the effort to model these accelerations. His team tested every possible natural mechanism: asymmetric outgassing, magnetic interactions, relativistic effects, even interactions with dark matter. Nothing fit the observations. The accelerations happened at irregular intervals but always resulted in Atlas maintaining a specific trajectory corridor. It was like watching a ship make course corrections, except there was no ship, just a mysterious object wrapped in an impossible shell, trailing an impossible tail, behaving in impossible ways. Stop. Let that sink in. We're not talking about small anomalies or minor mysteries. Every single aspect of Atlas violates our understanding of physics. The shell that shouldn't exist, the tail that points the wrong direction, the chemistry that can't happen in space, the accelerations that have no explanation, the rotation that maintains impossible precision. Scientists don't use the word impossible lightly. It's reserved for things that truly cannot happen within our understanding of natural law. and Atlas had crossed that line repeatedly, consistently, undeniably. The public was starting to notice. News outlets picked up the story, though most focused on sensational angles rather than the genuine scientific mystery. Social media exploded with theories ranging from alien probes to interdimensional visitors. Conspiracy theorists claimed government cover-ups. Science communicators struggled to explain why this was different from previous mysteries. Because it was different. Fundamentally different. When Oumuamua was discovered, its odd shape and slight acceleration sparked wild speculation. But ultimately, scientists could propose natural explanations that, while uncertain, were at least physically possible. Oumuamua was weird but not impossible. Atlas was impossible. Dr. Maria Rodriguez at the Instituto de Astrofísica de Canarias put it best. We're not looking at something that challenges our models. We're looking at something that exists outside our physics. Either our understanding of natural law is completely wrong, or we're observing something that operates by different rules. The different rules hypothesis gained traction among theorists. Perhaps Atlas came from a region of space where physics worked differently. Perhaps it carried with it some remnant of conditions from another part of the universe. Perhaps, and this was the most radical suggestion, it wasn't entirely in our dimension. These weren't fringe ideas from questionable sources. These were serious proposals from respected scientists, published in peer-reviewed journals, discussed at major conferences. The impossible nature of Atlas had pushed mainstream science to consider possibilities that would have been laughed at just years earlier. But we need data, not speculation. The James Webb Space Telescope provided the next breakthrough. Its infrared observations revealed temperature variations within the ghost shell that followed no known thermal model. Parts of the shell were colder than the background of space, a physical impossibility unless energy was being actively removed. Other parts showed rapid temperature fluctuations that suggested energy was being channeled in ways we couldn't understand. The temperature map looked like a circuit diagram, with cold zones and hot zones arranged in patterns that suggested purpose rather than random distribution. Energy was flowing through the shell in organized ways, creating what appeared to be a thermal structure within what should have been dispersing dust. Dr. James Patterson at NASA's Goddard Space Flight Center led the thermal analysis. His findings were stark. The shell was acting as a heat engine, moving energy in ways that violated thermodynamics. Cold spots were getting colder. Hot spots were maintaining temperature despite radiating energy to space. The entire system was fighting entropy and winning. That's when the first models of energy extraction appeared. If the shell was somehow harvesting energy from the vacuum of space, tapping into quantum fluctuations or zero-point energy, it could explain the impossible thermal behavior. But that explanation required physics we hadn't proven, technologies we hadn't, imagined processes we thought were impossible. Yet there it was, visible in our telescopes, defying our understanding. The anti-tail continued evolving. New filaments appeared, weaving between existing ones in complex braids. The structure was becoming more elaborate, not less. Time-lapse animations showed the tail growing like a living thing, extending new tendrils that followed mathematical patterns nobody recognized. Dr. Kevin Wu at Beijing Observatory made the connection nobody expected. The patterns resembled Julia sets, mathematical structures from chaos theory. But Julia sets are abstract mathematical concepts, not physical structures. They exist in calculation, not reality. Yet Atlas's antitail was creating them in physical space, built from dust and gas and impossible physics. The mathematical nature of the pattern suggested something profound. Whatever was creating these structures understood mathematics at a level that translated directly to physical form. This wasn't random chance creating seemingly meaningful patterns. This was deliberate construction using mathematical principles as a blueprint. We need to pause here and consider what this means. Mathematics is often called the language of the universe. We use it to describe natural phenomena, from the orbit of planets to the behavior of subatomic particles. But mathematics is our tool for understanding nature. Nature doesn't use mathematics, it simply behaves in ways we can describe mathematically. Atlas appeared to be using mathematics directly, building with it, creating physical structures based on abstract mathematical principles. The ghost shell's rotation followed numerical sequences. The antitail grew according to geometric progressions. The thermal patterns matched mathematical models of information flow. It was as if Atlas was a mathematical object expressing itself in physical form. Dr. Yuki Tanaka at the University of Tokyo proposed that Atlas might be a form of crystallized mathematics, a theoretical concept where mathematical relationships become physical reality. It was an insane idea that made perfect sense given what they were observing. If consciousness could manipulate reality at quantum levels, if information was more fundamental than matter, if the universe was computational at its core, then Atlas might be the proof. But proof of what exactly? The organized carbon chains were developing into more complex structures. New spectroscopic observations showed amino acid precursors, nucleotide bases, even hints of self-organizing polymers. The ghost shell wasn't just performing chemistry, it was performing biochemistry, creating the building blocks of life in the harsh vacuum of space. This went beyond impossible. This was revolutionary. Life as we understand it requires specific conditions: liquid water, appropriate temperatures, protection from radiation, concentrated chemicals. Space provides none of these, yet Atlas's shell was creating biological molecules anyway, assembling them from raw materials that shouldn't even be there. Dr. Rachel Green at the Astrobiology Institute led the biological analysis. Her team identified over 40 distinct organic compounds in the shell, with new ones appearing in each observation. The molecules weren't random, they showed signs of selection, as if certain chemical pathways were being favoured over others. The implications for astrobiology were staggering. If complex organic chemistry could happen in open space, if biological molecules could form without planets or stars, then life might be far more common and far stranger than we ever imagined. Atlas might be showing us that life doesn't need the conditions we thought it did. Or Atlas might be life itself, just not life as we recognise it. The idea had been proposed before, that life might exist in forms we couldn't recognise. Plasma beings in stars, quantum consciousness in empty space, information-based life in the cosmic web. But those were theoretical possibilities. Atlas was real, observable, and creating biochemistry before our eyes. As observations continued, patterns emerged in the chaos. The shell's rotation synchronized with the antitail's growth. Temperature fluctuations matched molecular formation rates. Acceleration events corresponded with structural changes. Everything was connected in ways that suggested not just order, but orchestration. Something was conducting this cosmic symphony. Whether that something was natural law we didn't understand, technology we couldn't imagine, or intelligence we couldn't recognize remained unknown. But the coordination was undeniable. The November approach would be crucial. As Atlas moved closer to the Sun, it would enter the range of more powerful telescopes. Solar observatories would track its interaction with the solar wind. Particle detectors would analyze material streaming from the shell. Radio telescopes would search for signals in the electromagnetic noise. Every observation platform available to humanity would focus on this impossible visitor. But we're getting ahead of ourselves. To understand why the November observations matter so much, we need to understand what Atlas has already taught us. Not about comets or interstellar objects, but about the nature of reality itself. Because that's what's really at stake here. When an object violates physical law repeatedly and consistently, we have three choices. We can assume our instruments are wrong, but dozens of independent observations rule that out. We can assume we're misinterpreting the data, but the observations are too clear, too consistent, too numerous for that to explain everything. Or we can accept that our understanding of physical law is incomplete, not slightly incomplete, fundamentally incomplete. The ghost shell tells us that matter can organize itself in ways we thought impossible. The anti-tail tells us that forces can work in directions we thought forbidden. The chemistry tells us that complex molecules can form in conditions we thought prohibitive. The thermal patterns tell us that energy can flow in ways we thought impossible. Each observation is a crack in the foundation of physics. Together, they are an earthquake. Dr. Michael Foster at Cambridge put it in perspective. We're witnessing something that makes us question basics we haven't questioned since Newton. Not refinements like relativity or quantum mechanics added, but basics. How forces work, how matter behaves, how energy flows. Atlas is showing us that our map of reality is missing entire continents. The scientific community was splitting into camps. Conservatives argued for natural explanations we hadn't discovered yet. Radicals argued for abandoning current physics entirely. Moderates searched for middle ground, ways to extend physics rather than replace it. But Atlas didn't care about our debates. It continued its approach, silent and impossible, wrapped in its ghost shell, trailing its anti-tail, building its molecules, defying our understanding. The organization within chaos extended beyond the visible structures. Radio observations detected patterns in the electromagnetic emissions from Atlas. Not random noise, but structured signals that repeated with modifications, like themes and variations in music. The signals weren't communication in any sense we recognized, but they weren't natural either. Dr. Sandra Miller at the Very Large Array led the radio analysis. Her team found 17 distinct frequency patterns, each with its own repetition cycle and modification scheme. The patterns interacted, creating interference that produced new patterns, which then influenced the original signals. It was like watching a conversation where the language itself was evolving. The signals contained no information in the conventional sense, no encoded data, no mathematical constants, no clear messages. Instead, they seemed to be the information, as if the pattern itself was the content. It was communication without communication, meaning without message. Some theorists suggested we were observing thought itself, not the communication of thought, but thought as a physical process. If consciousness was fundamental to the universe, if observation really did collapse quantum functions, then perhaps Atlas was a macro-scale quantum object. Its state determined by observation itself. It was a wild idea that explained nothing and everything simultaneously. The practical implications were becoming urgent. Atlas would reach perihelion, its closest approach to the Sun, in late December. The heat and radiation would test the ghost shell's stability. The solar wind would interact with the anti-tail in ways we couldn't predict. The complex chemistry might accelerate or collapse entirely. We had weeks to gather as much data as possible before Atlas either revealed its secrets or disappeared into the solar glare. Emergency funding was approved for observations. Telescope time was redistributed. New instruments were rushed into service. The scientific community mobilized in ways not seen since the discovery of gravitational waves. This wasn't just another astronomical event. This was a potential revolution in our understanding of the universe. But revolutions in science don't come easily. Every observation that challenged physics also challenged careers built on that physics. Papers were rejected for being too speculative. Grants were denied for proposing impossible research. Scientists who spoke too boldly found themselves marginalized. The ghost shell didn't care about academic politics either. New observation showed it was developing layers, concentric shells nested inside each other like Russian dolls. Each layer rotated at a different rate, in different directions, creating shear forces that should have destroyed the entire structure. Instead, the layers seemed to stabilize each other through mechanisms nobody could explain. The anti-tail had grown to enormous proportions, stretching millions of kilometers toward the Sun. Its filaments had woven themselves into complex structures that looked almost crystalline in high-resolution images. The patterns were beautiful and terrifying. Beautiful because they showed order on cosmic scales. Terrifying because that order shouldn't exist. We were running out of analogies, out of comparisons, out of ways to relate what we were seeing to anything in human experience. Atlas existed in a category of its own, following rules we couldn't learn because we couldn't even identify what game was being played. Dr. Elizabeth Carter at the Planetary Science Institute made a crucial observation. The patterns in Atlas's behavior showed memory. Actions taken weeks ago influenced current behavior. The shell remembered its previous states and built upon them. The anti-tail grew according to patterns established when it first formed. The chemistry progressed along pathways determined by earlier reactions. Atlas wasn't just an object. It was a process with history, with memory, with something approaching purpose. This is where our story takes its most profound turn. Because recognizing purpose in nature, real purpose, not the appearance of purpose, changes everything about how we understand the cosmos. It suggests the universe isn't just a machine running according to fixed laws. It suggests intention, direction, meaning beyond mere mechanism. For centuries, science has stripped purpose from nature, explaining everything through cause and effect, through forces and reactions, through mathematics and probability. Purpose was something humans projected onto nature, not something nature possessed. Atlas was challenging that fundamental assumption, but we're getting ahead of ourselves again. The November observations haven't happened yet in our story. We're still in early November, watching Atlas approach, gathering data, struggling to understand. The shell is sharpening, the tail is growing, the chemistry is building, and every day brings new impossibilities. The public pressure was mounting. News outlets wanted explanations. Governments wanted assessments. The military wanted threat analysis. Everyone wanted to know what Atlas was, where it came from, and what it meant for humanity. Scientists had no answers, only observations that raised more questions. Some called for transparency, sharing all data publicly, crowdsourcing analysis, bringing in perspectives from outside traditional astronomy. Others argued for caution, avoiding panic, preventing misinterpretation, maintaining scientific rigor. The debate reflected larger tensions about science's role in society, about who owns cosmic discoveries, about how we should respond to the truly unknown. But while humans debated, Atlas continued its journey. Silent, impossible, inevitable. The latest models suggested Atlas would survive perihelion. The shell was too stable, the structure too resilient. It would swing around the sun and head back to interstellar space, carrying its mysteries with it. We had one chance to understand it, one window of observation, one moment in cosmic time where Atlas and humanity intersected. What we learned in that moment might reshape our understanding of everything, or it might leave us with more questions than we started with. The ghost shell was teaching us that matter could organize itself in ways that suggested intention. The anti-tail was showing us that forces could be directed in ways that implied control. The chemistry was demonstrating that life's building blocks could form in conditions that required revision of biology itself. The thermal patterns were revealing that energy could be structured in ways that demanded new physics. Each lesson was profound. Together they were revolutionary. But revolutions require more than observations. They require understanding, integration, acceptance. They require us to abandon comfortable certainties and embrace uncomfortable possibilities. They require courage to follow evidence wherever it leads, even when it leads to impossible places. Atlas was leading us to the most impossible place of all, a universe where consciousness might be as fundamental as matter, where purpose might be as real as physics, where the cosmos might be more than a vast machine. It might be something aware, something intentional, something alive in ways we're only beginning to glimpse. We stand now at the threshold of that revelation. The November 21st observations will use the full power of the James Webb Space Telescope, combining its instruments in ways never attempted before. The solar observatories will track Atlas through perihelion. Radio telescopes worldwide will listen for changes in its mysterious signals. And somewhere in that data might be the key to understanding not just Atlas, but our place in a cosmos far stranger than we imagined. The ghost shell continues its impossible rotation. The anti-tail reaches toward our sun with filaments of organized matter. The chemistry builds toward complexity we can observe but not explain. And in all of this, patterns emerge that suggest something profound. The universe might not be silent after all. It might be speaking to us in languages we're only now learning existed. What Atlas represents isn't just a challenge to physics or astronomy. It's a challenge to our fundamental assumptions about reality. It asks us to consider possibilities we've dismissed, to entertain ideas we've rejected, to open our minds to a cosmos that operates on principles we haven't discovered, because we haven't been looking for them. We've been searching for signs of life in the universe by looking for biology like ours, chemistry like ours, planets like ours. Atlas suggests we've been looking for the wrong things. Life might not need water or warmth or worlds. Intelligence might not need brains or bodies or biology as we know it. Consciousness might not need any of the substrates we associate with awareness. The ghost shell might be showing us consciousness at scales we never imagined. The anti-tail might be revealing intention in forms we never conceived. The chemistry might be demonstrating that life is far more fundamental, far more widespread, far more alien than our Earth-centered perspectives allowed us to see. This is what makes Atlas different from every other astronomical discovery. It's not just showing us something new about the universe, it's showing us that our entire framework for understanding the universe might be inadequate. We're not just missing pieces of the puzzle, we might be playing the wrong game entirely. As we watch Atlas approach perihelion, we're really watching our understanding of reality approach a crossroads. Either we'll find explanations that fit within extended versions of current physics, or we'll be forced to acknowledge that the cosmos operates on principles so foreign to our experience that we'll need new languages, new mathematics, new philosophies to even begin comprehending them. The organised carbon chains have evolved into structures that show signs of self-replication. Not life as we know it, but something that copies patterns, that preserves information, that builds complexity from simplicity. It's happening in the vacuum of space, powered by mechanisms we can't identify, following rules we can't determine. Dr. Patricia Newman at the Santa Fe Institute studies complex systems, and she sees in Atlas something that transcends traditional categories. It's not alive or dead, natural or artificial, conscious or unconscious, she explains. It's something else, something that doesn't fit our binary classifications. It's process and thing, observer and observed, cause and effect simultaneously. This isn't mysticism, it's observation. Atlas exhibits properties that require us to think beyond our usual categories. The shell is both structure and process. The tail points both away and toward. The chemistry builds up and breaks down simultaneously. Everything about Atlas exists in states of paradox that resolve only when we stop trying to force it into our conceptual boxes. The November 21st observation run will mark a turning point. Armed with everything we've learned, using every instrument available, coordinating observations across the electromagnetic spectrum, we'll make our most comprehensive attempt to understand Atlas. The data collected that day will take years to fully analyse, but initial results should tell us whether we're dealing with new physics or entirely new categories of existence. The preparations are unprecedented. Telescopes are being calibrated to precisions never achieved before. New software is being written to analyse patterns our current programs might miss. Interdisciplinary teams are forming, bringing together physicists, chemists, biologists, mathematicians, philosophers, even artists. Because understanding Atlas might require perspectives science alone can't provide, we're preparing for more than observation. We're preparing for revelation. Because that's what Atlas promises. Revelation about the nature of reality itself. Every impossible feature, every broken law, every defied prediction points toward the same conclusion. Our universe is far more mysterious, far more complex, far more alive than we ever dared imagine. The ghost shell spins in perfect mathematical precision while being composed of chaos. The anti-tail reaches toward our sun while being pushed away from it. The chemistry creates life's foundations while being hostile to life as we know it. These aren't contradictions, they're invitations to expand our understanding until the contradictions resolve into higher truth. This is the gift Atlas brings, wrapped in impossibility and tied with paradox. It's showing us that the cosmos isn't just vast, it's deep in ways we haven't fathomed. It operates not just on multiple scales of space and time, but on multiple scales of reality itself. What we see as impossible might be everyday occurrence in parts of the universe operating by different rules, or might reveal that the rules themselves are far more flexible than we believed. The implications extend beyond science into philosophy, spirituality, even consciousness studies. If matter can organize itself purposefully, if information can structure reality, if mathematics can become physical, then the boundaries between mind and matter, between observer and observed, between consciousness and cosmos become far less clear. We might be witnessing evidence that consciousness isn't produced by brains, but is somehow fundamental to the universe itself. Atlas might be showing us that awareness exists at scales and in forms we never imagined. The ghost shell might be thought made visible. The anti-tail might be intention given form. The chemistry might be creativity expressed in molecules. These ideas sound fantastic, even absurd, but they're forced upon us by observations we can't dismiss. Atlas exists. Its impossible features are real. And reality, as Atlas keeps demonstrating, is far stranger than we thought possible. As we count down to the November 21st observations, we're really counting down to a moment of choice. We can cling to our current understanding, forcing increasingly complex explanations onto increasingly impossible observations. Or we can let Atlas teach us, let it show us new ways of seeing, new ways of thinking, new ways of being in the cosmos. The universe has sent us a teacher wrapped in mystery. The ghost shell is our classroom. The anti-tail is our curriculum. The impossible chemistry is our homework. And the lesson, if we're brave enough to learn it, might be that we're not just observers of the cosmos, we're participants in something far grander than we ever imagined. Atlas approaches perihelion carrying questions that could reshape our understanding of everything. It moves through our solar system like a key through a lock, potentially opening doors to comprehension we didn't know existed. What lies beyond those doors remains unknown, but Atlas is showing us they're there, waiting to be opened. The countdown has begun. Telescopes are turning, computers are processing, scientists are watching. And somewhere in the space between Earth and Sun, an impossible object wrapped in an impossible shell, trailing an impossible tail, continues its journey, carrying secrets that might transform our understanding of the universe itself. On November 21st, when the James Webb Space Telescope turns its golden mirror toward Atlas, when all our instruments focus on this cosmic mystery, when humanity's combined observation power concentrates on a single point in space, we won't just be studying an object, we'll be confronting the boundaries of our understanding, the limits of our knowledge, the edges of what we thought was possible. What we discover might confirm that the universe is stranger than we imagined, or it might reveal that we haven't imagined nearly enough. Either way, Atlas has already succeeded in its most important mission. It has reminded us that the cosmos still holds profound mysteries, that discovery is not dead, that wonder is not obsolete. The ghost shell continues spinning, holding its impossible perfection against all forces that should destroy it. The anti-tail reaches sunward, defying every law that governs matter in space. The chemistry builds toward complexity that shouldn't exist, and in observing these impossibilities, we're forced to confront a possibility that science has long avoided. The universe might not be a machine. It might be something far more interesting. As this documentary reaches its conclusion, we find ourselves not at an ending, but at a beginning. Atlas hasn't given us answers. It has given us better questions. It hasn't solved mysteries. It has revealed that the mysteries are far deeper than we knew. It hasn't confirmed our understanding. It has shown us how much we still don't understand, and that's perhaps the most valuable gift any discovery can offer. In an age where we sometimes feel we've mapped the cosmos, where we think we understand the fundamental laws, where mystery seems endangered by explanation, Atlas reminds us that we've barely scratched the surface of reality. The universe Atlas reveals isn't the clockwork cosmos of classical physics. It isn't even the probabilistic cosmos of quantum mechanics. It's something richer, stranger, more alive with possibility. It's a cosmos where matter might have memory, where forces might have intention, where chemistry might have creativity. It's a cosmos where consciousness might not be an accident, but an integral feature, where purpose might not be projection, but perception of something real. We stand at the edge of this revelation, watching Atlas approach the sun, waiting for observations that might change everything. But the change has already begun. Atlas has already forced us to question assumptions so fundamental we forgot they were assumptions. It has already shown us that impossible is just another word for not yet understood. The ghost shell will eventually disperse, the anti-tail will eventually fade, the chemistry will eventually cease. Atlas will swing around the sun and head back to interstellar space, carrying its mysteries with it. But what it leaves behind, the questions it raised, the assumptions it shattered, the possibilities it revealed, will remain with us forever. We'll never look at the cosmos the same way again. We'll never assume we understand the fundamental rules. We'll never forget that somewhere out there, objects exist that follow different laws, that demonstrate different possibilities, that hint at a universe far more magnificent than our small planet-bound perspectives could imagine. Atlas came to us as a visitor from beyond, wrapped in impossibility, trailing paradox, building complexity from emptiness. It came not to give us answers, but to show us that our questions weren't big enough. It came to remind us that the universe isn't just vast in space, but vast in possibility, that reality isn't just deep, but multi-dimensional in ways we're only beginning to perceive. As we prepare for the November 21st observations, as we ready our instruments and theories and minds for whatever Atlas might reveal, we're really preparing for a new chapter in humanity's relationship with the cosmos. A chapter where mystery isn't the enemy of understanding, but its companion. Where impossibility isn't the end of investigation, but its beginning. Where wonder isn't childish, but essential to comprehending a universe that's far more wonderful than we dared believe. The ghost shell spins on, perfect and impossible. The anti-tail reaches toward our sun, defiant and unexplained. The chemistry builds toward complexity, purposeful and paradoxical. And watching it all, We stand at the threshold of discovery, knowing that whatever we learn will raise more questions than it answers, will open more doors than it closes, will reveal more mystery than it resolves. And that's exactly as it should be, because a universe without mystery wouldn't be worth living in. A cosmos completely understood wouldn't inspire wonder. Reality fully mapped would lose its magic. Atlas reminds us that we live in a universe that will never be fully known, never be completely understood, never be reduced to simple equations or easy explanations. We live in a universe that's alive with possibility, rich with mystery, infinite with wonder. Atlas is our reminder, our teacher, our invitation to see the cosmos not as something to be conquered by knowledge, but as something to be explored with awe. It shows us that every answer opens new questions, that every discovery reveals new mysteries, that every step forward in understanding shows us how much further we have to go. And that journey, that endless, wonderful, impossible journey toward understanding, is perhaps the greatest gift the universe offers. Atlas is just the latest messenger wrapped in its ghost shell, trailing its anti-tail, carrying its impossible chemistry through our solar system, like a banner declaring, "The universe is stranger than you know, more wonderful than you imagine, and you've only just begun to discover its secrets." On November 21st, we'll point our telescopes and hold our breath and wait for revelation. But the true revelation has already arrived. It's the realization that we live in a cosmos where objects like Atlas can exist, where impossibility is possible, where mystery isn't the exception but the rule. The countdown continues. The ghost shell spins, the anti-tail grows, the chemistry builds, and somewhere between question and answer, between known and unknown, between possible and impossible, Atlas makes its journey through our solar system, a visitor bearing the most precious gift of all. Wonder at the universe we're privileged to inhabit, to observe, to be part of in ways we're only beginning to understand.